have titled Determination of the Molecular Weight of Polymer from Viscosity Measurements. This experiment will describe some physical properties of polymer, that mean the molecular weight of polymers, and we use the viscosity measurements to calculate the average molecular weight of the polymer. The aim of these experiments included the flow rates of a series of dilutions of polymer solutions were measured using an Austrold viscometer, and we will explain this type of viscometer in the next slide. And the intrinsic viscosity solution was found, and the average molecular weight of these polymers was determined. That means we will take many different viscosities and we calculate it, then use this type of viscosities to calculate the molecular weight of polymers. Molecular weight is a very important factor for the characterization of polymers, and the different techniques are used for determination of molecular weight of polymers. For example, gas permeation chromatography, light scattering, end group analysis, and etc. type. One of the simplest methods for the determination of molecular weight of polymers is viscometry. It is not absolute method, so it is relative method. This is important. Not absolute methods, but it's relative method. Viscosity is a measure of the resistance of a fluid to deformation under stress. We have fluid, and the resistance for the molecules of this fluid to deformation under stress. It describes a fluid's internal resistance to flow and is a measure of fluid fraction. Liquid viscosities can be accurately measured using a device known as the Austrold viscometer, which is a device for measuring flow times of liquids. This shape of Austrold viscometer, you can see here, we have A point and we have B point, and we have inside it capillary tube, okay? And we will put the liquid or the solutions we prepare it inside the viscometer and calculate the flow time from A point to B point, and this is flow time for this solution inside the viscometer, okay? And we will repeat it with solvent and with dilution solutions to calculate many flow time for different solutions. Now we have many different type of viscosity, included number one, relative viscosity, have these symbols, lambda r. Relative viscosity is the ratio of solution viscosity, okay, to solvent viscosity, lambda naught relative viscosity equal lambda viscosity of solution of the polymer we use it to lambda naught viscosity of solvent. That means flow time of solution of polymers to flow time of the solvent. In here, where lambda and lambda naught are the viscosity of polymer solution and solvent respectively. Number two, specific viscosity, lambda SP equals viscosity of solution to viscosity of solvent minus 1, or specific viscosity equal relative viscosity minus 1, because viscosity of solution to viscosity of solvent is a relative viscosity. So specific viscosity equal relative viscosity minus 1. Type number 3, reduced viscosity, lambda RED equal specific viscosity to concentrations of solution. We know as concentrations increase, that means viscosity increase, and the resistance of molecule for the solution will become higher because the concentrations will increase, and vice versa. Now, we have many concentrations. We will prepare about 5 solutions with different concentrations. So reduce viscosity equals specific viscosity to concentrations of the solution of polymer. Number 4, inherent viscosity. You know, viscosities are determined at a single concentration, and inherent viscosity as defined below and is used as an approximate indication of molecular weight. So lambda INH, that's mean inherent viscosity, equal ln relative viscosity to concentrations. Ln relative viscosity to concentrations. But in here, be patient, concentrations must be gram per 100 ml, okay? And I will explain that in the lab, inshallah. Number 5, intrinsic viscosity. By using Markov-Wick equations, these equations give me the relationship between viscosity and molecular weight. Okay, between viscosity and molecular weight equal viscosity equal kmh squared. In here, viscosity, that means intrinsic viscosity, equal K constant, M average molecular weight for the polymer solution, A constant. Okay. Now by logarithm viscosity lambda equal A logarithm molecular weight plus in here, please change it, logarithm K plus logarithm K. Okay, plus logarithm K. And here we need add log for the K constant, where lambda is intrinsic viscosity, M average molecular weight, K and A constant. But constant for what? Constant for the specific polymer and solvents. That means if we use, for example, polystyrene as a polymer solution, that means we have K and A for the polystyrene polymers. But when change it to another type, for example, polyvinyl alcohol, that means we must be change the constant. That means we have another A and another K for the different type of polymers. Also, we said for specific polymer and solvents. For example, if we use toluene as a solvent, I have A and K constants for this solvent. But when I change it to another type, for example, benzene, that means I need another amount for the K and A constants. That means A and K constants for specific polymer and solvents. And also, A and K depend on the temperature and solvent. What's the meaning depend on the temperature? That means when the temperature becomes, for example, 25 degrees centigrade, I have amount for A and K. But when I change the temperature, for example, to 45, the amount of K and A constants will change. And we will explain that in the next table. So, average molecular weight can be calculated by above equations. That means Markov equations by determination the intrinsic viscosity and by the now A and K. Now, if I calculate intrinsic viscosity, A constant now, K constant now, just still the average molecular weight unknown. And the above logarithm equations is the straight line equations, which shows that log lambda and log molecular weight have linear relationship. Now see this table included different type of polymers with different solvent, with different temperature, and this is average molecular weight for this type of polymers, and this is amount of K constant and A. If you see here, if I use polystyrene, okay, with cyclohexane as a solvent, okay, with 35 degrees centigrade temperature, I will use 18 multiplied 10 square 3 for K amount constant and A equal 0.5. And if I use also polystyrene, but I change the solvent to use benzene, okay, to use benzene with 25 degrees centigrade, the amount of K will change and the amount of A will change. Also for another type of polymers, okay? In here, we have different amount, different type of polymers with different solvent. So we must be change the amount of K and A. That means A and K constant will change when or depends on the temperature, solvent, and specific polymer. Now, how we can calculate the intrinsic viscosity? By drawing between reduce ln relative viscosity over C, okay, our concentrations, with reduced viscosity, okay, and here we have concentrations, that's mean reduced viscosity, that's mean we have inherent viscosity, okay, when I draw between inherent viscosity in here with concentrations, I will get this line, okay, from up to down. And if I draw between concentrations with reduced viscosity, I will get another line from up to down, okay? If we draw one line, this or this, that's okay. And but for accurate results, we will draw the two line, okay, and the intercept in here, this amount from 0 to this number, for example, equal 5, the intercept in here will equal intrinsic viscosity. This amount, I can use it in here in these questions, okay, in Mark Wink questions, and still a noun, K noun, okay, and intrinsic viscosity will become now from the intercept, okay, and still the molecular weight unknown, okay. And I will explain it in the lab, inshallah. The procedure included, firstly, keep the temperature constant at 25 degrees centigrade. That means we need to prepare a water bath, okay, water bath, and the temperature must be constant because if the temperature will change, that means the amount of the constants A and K will change also. Now, by using the Ostwald viscometer, okay, by using the Ostwald viscometer, this Ostwald viscometer, okay, put it inside the water bath, okay, and put inside it the solvent we use it for this experiment. We will use water as a solvent and polyvinyl alcohol as a polymer sample. Firstly, put inside the viscometer amount of water, okay, and push the air in here by using pump, okay. The water will move through the capillary tube until fall all this bubble, okay, and still in here. Now release the pump, air pump, okay. What happened for the water will move down by gravity, okay. When the water move down, we can calculate the time of the moving of water from the A point to B point. This time, okay, you can see in here full bubble, and in here the bubble will become without any solvent or solution. So the time by using timer clock, the time from the A point to B point, this called flow time of solvent. Flow time of solvent. That means T naught. Flow time of solvent. So firstly, keep the temperature constant, 25 degrees centigrade in the water bath, and then add the solvent, distilled water, into the household viscometer and calculate the flow time, T naught. Repeat the above process, okay, at least 2 to 3 times and calculate the average flow time of solvent. Then wash the viscometer with same solvent, okay, and dry it, not using another solvent, with same solvent. That means with water, okay, using hot water, no problem, and dry it to calculate the flow time of solution. Now we know how calculate the flow time of solvent. Same process, we'll use it for solution. Firstly, we will prepare of polyvinyl alcohol solution by take 1 gram of polyvinyl alcohol and dissolve it in 25 milligram distilled water by using this volumetric flask, okay, and put inside the household viscometer, okay, after prepare the polyvinyl alcohol solution, okay, dissolve all the polymer particles inside the volumetric flask, okay, have a 25 ml as a volume. Now I have polyvinyl alcohol solution. Take 15 ml, okay, 15 ml must be noun volume we need, take 15 ml of this solution of polyvinyl alcohol solution, okay, and put it inside the outward viscometer from this side, okay, from this side, and also same process by using air pump, push the air and the polyvinyl alcohol solution will move up through the capillary tube and fall all the bubble, okay, and leave it the air bubble, okay, and we can calculate the flow time of solution, polyvinyl alcohol solution from A point to B point. This is T, flow time of solution. Now, we will add to this solution, the polyvinyl alcohol solution is still inside the outward viscometer, okay, and we will add 2 ml distilled water, okay, 2 ml distilled water to this solution with briefly shaking, okay, with briefly shaking. What's happened? We will dilute it. This solution, the concentrations will dilution. That means the viscosity will decrease and the resistance of polyvinyl alcohol molecules will decrease, okay? That means the flow time in here will also decrease, okay? Also decrease. Now again, same process, calculate the time, flow time from A to B point, and this is T2, flow time for solution number 2, because we have different concentrations. Now again, add another 2 ml with briefly shaking. Now the concentrations will change. That means viscosity will change. That means the resistance of molecules will change. And also the flow time of solution will change. Repeat it 5 times. That means we will add 10 ml divided to 5 parts, 2 ml, 2 ml, 2 ml, 2 ml, and 2 ml. That means I have 5 different concentrations, okay, with 5 different flow time, with 5 different flow time. After that, prepare this table, included polymer concentrations, gram per 100 ml, flow time, relative viscosity, specific viscosity, reduced viscosity, and inherent viscosity. Now we have a pure solvent, distilled water. That means T naught in here, amount of flow time for distilled water. T1, T2, T3, T4, T5. Flow time for the different concentrations of polyvinyl alcohol. And we will explain how to calculate the concentrations of polyvinyl alcohol by using dilution law, N1B1 equal N2B2, and I will explain it in the lab, inshallah. And by using T over T naught, flow time of solution number 1, to flow time of solvent, I will calculate relative viscosity. That means relative viscosity 1, 2, 3, until 5. Also specific viscosity 1, 2, 3, until 5. Reduced viscosity 1, 2, 3, until 5. And inherent viscosity 1, 2, 3, 5, until 5. Okay, using the amount of this type of viscosity to draw the line between the concentrations and firstly between concentrations and reduced viscosity to get this line, and then by concentrations with inherent viscosity to get this line, and take the intercept in here equal the intrinsic viscosity and use it in the Markov equations using logarithm, okay, to calculate the average molecular weight of the polyvinyl alcohol solution. That means we will get the molecular weight of polymer, or specific for the polyvinyl alcohol with the different solutions. That mean using the different concentrations with that mean different viscosities. Okay, by using a simple method, by using household viscometer, and you can see this method not absolute, but it is relative methods. In the lab, inshallah, we will
Okay, so this video is use how the viscosity can be doing the process and how to calculate the time flow. टाइम फ्लो कसा काढायचा आहे त्या व्हिडिओवरून तुमच्या थोडंसं लक्षात आलं असेल. ओके, सो this is the solutions, the percent of polymer solutions can be prepared with the help of this tabular form. या टॅब्युलर फॉर्मने तुम्ही काय करू शकता ते पर्सेंट सोल्युशन्स तयार करू शकताय 20 ml total volume. Okay, and here we just see the k value is given, that is 20 into 10 raised to power minus 5, and a is the constant for the 0.76. आता this k value and a value, it is different for the different polymer solutions and different for the temperatures. समजा आता तुम्ही जर पॉलिव्हिनिल अल्कोहोल घेतलं किंवा पॉलिस्टायरीन घेतलंय, दुसरा जर कुठला तुम्ही जर पॉलिमर घेतला असेल तर त्याची ए व्हॅल्यू आणि त्याची के व्हॅल्यू ही वेगवेगळी असणार आहे आणि त्याच्या टेम्परेचर नुसार सुद्धा ती के व्हॅल्यू वेगळी. सो द स्पेसिफिक polymer, specific temperature, and the specific what you called it is the temperature and specific concentrations of a polymers. So this k value is different. या प्रत्येकांसाठी के व्हॅल्यू ह्या वेगवेगळ्या असणार आहे. सपोज आता आपण पॉलिस्टायरीन जर घेतलं असेल तर त्याची 0.676 आहे. तर पॉलिस्टायरीन वेगळ्या टेम्परेचरला असेल, हे रूम टेम्परेचरला त्याचं काय आहे ए व्हॅल्यू आहे. पण रूम टेम्परेचरला पेक्षा जर वेगळं टेम्परेचर असेल तर ए व्हॅल्यू अँड के व्हॅल्यू विल बी different. Okay, so just keep in your mind, but it is a constant. Okay, and for the particular temperature and particular specific polymer. Now observe, you make a observation table like this. Okay, अशा पद्धतीने ऑब्झर्वेशन टेबल तुम्ही तयार करायचा आहे. ऑब्झर्वेशन टेबल मध्ये तुमचं कॉन्सन्ट्रेशन ऑफ अ पॉलिमर सोल्युशन्स, डिस्टिल वॉटर अँड 0.1, 0.4, 0.6, 0.8 and 1% solution. Then here time flow in second. So this is the time flow in second, and this is the, we can calculate the mean of this one. हे मीन तुम्हाला काढून घ्यायचं आहे. हे रिडिंग्स तुम्हाला मी प्रोव्हाइड करणार आहे. ओके, सो या रिडिंग वरून तुम्ही काय करायचं आहे, मीन काढायचं आहे. त्याच्यावरून तुम्हाला काय काढायचं आहे, देन we can find out the relative viscosity n upon n0. N means this the solvent, mean of this solvent, and n0 means the solutions. 0.1 साठी this 1, 0.2, 0.4, 0.6, 0.8. So we can find out the relative viscosity. So then specific viscosity means n upon n0 minus 1 म्हणजे relative viscosity minus 1. So and on the basis of this we can find out this specific viscosity upon C. C means 0.2, 0.4, 0.6, 0.8 and 1. So on the basis of this we can find out the the relations between the specific viscosity and the concentrations. Now this value we are using to find out the graph. To draw the graph काढण्यासाठी आपल्याला ही व्हॅल्यूज काय करायची आहे, यूज करायची आहे. So the calculations we do here, the relative viscosity means 179.6. This is your the constant, this is your the time flow for the solutions 0.2%, and divided by n0 means the this mean time flow of your solvent, that is distilled water 170.5. So when you calculate it, it comes the value of this one. We'll get the value of relative viscosity. In this way, the specific viscosity from this one. So this is the value of your relative viscosity minus 1 will get the specific viscosity. त्याच्यावरून तुम्हाला काय मिळेल? Specific viscosity. So in this way we do the calculations for all the concentration of your polymer solutions. Okay. So this is, आता हे मी इथं हाईड का केलंय कारण तुम्हाला ते कॅल्क्युलेशन्स करून मला पाठवायचे. आता so now the specific viscosity upon concentration. So once you find out the 0.0531 specific viscosity divided by concentration of particular solute 0.2, so you'll get the this value or relations of this one. So these values are used for the to draw the graph versus this concentration of your solutions. Okay, polymer solutions. And from this value we can find out, once we get the from the graph we intrinsic viscosity, then we can find out the molecular weight of these solutions or the polymer. M equals to a root of intrinsic viscosity upon k. So we know the value of k, we know the value of a, and from the graph we know the value of intrinsic viscosity. So once do the calculations with this, we can find out the molecular weight of your polymers. So this is the value, we can find out the results. So this is the results. In the results we are given intrinsic viscosity and the molecular weight of a given polymer. So this intrinsic viscosity, this value is given from the graph. This viscosity or this molecular weight of the solutions or the polymers given from the your m equals to a root of intrinsic viscosity upon a. So points to be remember when you performing the experiment in a real lab. लॅबोरेटरी मध्ये जर तुम्हाला हे एक्सपेरिमेंट करायचं असेल तर तुम्हाला ऍप्रन असणं गरजेचं आहे. सो वर्किंग टेबल्स सगळे ग्लासवेअर्स हे क्रोमिक ऍसिड डिस्टिल वॉटरनी ड्राय आणि वॉश करून ड्राय करणं गरजेचं आहे. सो क्लीन कॅलिब्रेट करणं, इलेक्ट्रॉनिक वेट बॅलन्स तुमचं कॅलिब्रेट करायला पाहिजे. You always use the apron and gloves in your hand. Then ensure the stopwatch. Stopwatch हा हॉट एअर मध्ये किंवा तुमच्या वर्किंग प्रॉपरली करते की नाही ते बघणं गरजेचं आहे. Clean all the glasswares with soap and distilled water once we do the before the experiment. So and after the experiments we can discard the use gloves and the waste materials into the this dustbin. So this is the points to be remember when you doing the actual experiment in the laboratory. Okay, so this is all about your the experiment, that is to determine the viscosity average molecular weight of a polymer. So अशा पद्धतीने आपल्याला हा एक्सपेरिमेंट कंप्लीट करून घ्यायचा आहे. ओके, यामध्ये काही अडचण असली तर नक्की मला फोन करा किंवा मेसेज करा. हा, आणि तुम्हाला याचे रिडिंग्स आहे ते रिडिंग्स मी तुम्हाला काय करतोय गुगल क्लासरूम वरती मी ते सगळे रिडिंग्स काय करतोय अपलोड करतोय. त्यावरून तुम्ही ते रिडिंग घ्या आणि हे प्रॅक्टिकल जर्नल्स कंप्लीट करा, कॅल्क्युलेशन्स करा, ग्राफ काढा. ग्राफ तुम्हाला अशा पद्धतीचा ग्राफ असणार आहे. सो दिस इज द नेचर ऑफ युअर ग्राफ. इथे तुम्ही आपण जे आता व्हॅल्यूज काढलाय दिस स्पेसिफिक विस्कोसिटी अपॉन सी, त्या व्हॅल्यू इथे येतील. इथे तुमचं कॉन्सन्ट्रेशन 0.2, 0.4, 0.6, 0.8 आणि 1%. देन पॉइंट तुम्ही हे करणार, त्यामुळे अशी स्ट्रेट लाईन मिळेल. इथपर्यंत काहीतरी स्ट्रेट लाईन येईल, पण त्याला एक्स्ट्रापोलेटेड केलं तरी इथे तुम्हाला इंटरसेप्ट मिळतोय आणि इंटरसेप्ट म्हणजे तुमची काय असतं इंट्रिन्सिक विस्कोसिटी. सो वी कॅन कॅल्क्युलेट द इंट्रिन्सिक विस्कोसिटी फ्रॉम द ग्राफ. ओके, यामध्ये जर काही डिफिकल्टी असेल किंवा काही प्रॉब्लेम असेल तर नक्की मला विचारा आणि याचे रिडिंग मी लगेच तुम्हाला काय करतोय गुगल क्लासरूम वरती टाकतो आणि त्यानंतर तुम्ही ते कॅल्क्युलेशन्स करून फिजिकलचे, आता एक बॅच तुमची अलीकडची बॅच कंप्लीट झाली, त्यांनी फिजिकलचे कॅल्क्युलेशन्स करून सगळे एक वन पीडीएफ फाईल तयार करून मला पाठवायची आहे. ईमेल मी तुम्हाला ग्रुपवरती टाकलेला आहे. गुगल क्लासरूम तुम्हाला माहित आहे आणि व्हॉट्सअप नंबर आपल्याकडे आहे, त्यामुळे सगळ्यांनी ती एक फाईल तयार करून पाठवा. दुसरी जी बॅच आहे तिकडची विशालची जी बॅच आहे त्या बॅच मध्ये आणि 2 प्रॅक्टिकल्स आपले घ्यायचे आहेत. म्हणजे पोटेन्शिओमेट्रीचं पहिलं झालेलं आहे, दुसरं आणि तिसरं पोटेन्शिओमीटर आपण कंप्लीट करणार आहे. तुम्हाला बाकीच्यांना जर जॉईन व्हायचं असेल तर होऊ शकता. ओके, नाउ आय एम गोइंग टू स्टॉप दिस डिस्कशन्स विथ दिस विस्कोसिटी to determine the molecular weight of polymers with the help of the viscosity methods. Okay. मीटिंग मी ते स्टॉप करतोय. सुमया आणि हे असेल तर अटेंडन्सचा स्क्रीनशॉट घेऊन मला पाठवा. ओके. काही डिफिकल्टी असेल तर बोलू शकता. आणखी आपल्याकडे 3 मिनिट आहे. येस. ओके, ठीक आहे. हर्षदा, काही डिफिकल्टी? ठीक आहे. कुणाला काही डिफिकल्टी नाही आहे असं समजून मी मीटिंग स्टॉप करतोय. ओके. नेक्स्ट लेक्चर, आता माझं लेक्चर कधी आहे? शुक्रवारी आहे. शुक्रवारी आपण नेक्स्ट प्रॅक्टिकल बघूया. पोटेन्शियोमेट्री असणार आहे आणि त्याची लिंक मी सोडणार त्याच्या आदल्या दिवशी. ओके.